Hello everyone. Let's just check how recovery is done in case of concurrent transactions. We have been talking about various recovery methodologies. So we will just try to apply them for a concurrently executing transaction and try to see. So when we say concurrent execution, there will be multiple transactions running at the same time and there will be interleaved log entries, because we know that they use a single memory block and single log. So for each transaction there is going to be a record, so it is going to be an interleaved record. So in case of system failure, during recovery it is difficult for the recovery system to backtrack all the logs, then start the recovering. So how these things are done in case of a concurrently executing system, we will try to see. We will try to see some of the methods first, which actually go hand in hand, or they mutually work on this in order to ensure data integrity and consistency. Then we will try to take up an example by seeing the log records and try to work with it. So when we talk about the methods, there are following 4 ways in which it can be done. One is interaction with the concurrency control. Then we have transaction rollbacks. Checkpoints play a very important role. Then we have restart recovery. So when I talk about interaction with concurrency control, we know that the concurrency control module of DBMS is responsible for ensuring concurrent execution without affecting the database consistency or integrity. We know, we have seen that it uses the two-phase locking protocol, or maybe time-stamped ordering where locks are not used, rather time-stamping is used to ensure serializability. Or we may even go by concurrent optimistic concurrency control, where we think that conflicts are very rare. So we allow the system to run as it is, and only during commit it will just check if there was any conflict happened. It is detected and resolved at that stage itself. So how this thing helps, or in during recovery, these mechanisms play a very crucial role, ensuring the transactions are correctly rolled back or it is done in a specific order. So what will happen during failure? The system retrieves the information from the logs and the transaction metadata so that it can determine which transaction needs to be undone or which has to be redone. So in case of commit log, it has to be redone. In case of abort log, it has to be rolled back. So this ensures data integrity and consistency, and there is no violation of our asset properties. Coming to the transaction rollback, it is undoing the effect. So it involves undoing the effects of the transaction that has not yet been committed due to error or abort conditions. So it restores the database to a state before the last commit, or otherwise before the transaction has begun, which was consistent enough. So when the system failures, the transaction that were in progress or incomplete need to be rolled back during recovery. For rolling back, it will use the record of the logs, that is the sequence of operations performed in each transaction is identified and reverses the changes. This is how the transaction rollback works. Okay, it will ensure that any uncommitted changes will not persist in the database, maintaining the data integrity. Coming to the checkpoint, checkpoints play a really very crucial role in avoiding the length of log records. What will happen is, these are nothing but periodic snapshots of the database where they record the specific intervals, that is like at up to that stage, whatever is the transactions that has been done, that is updated to the database, and the log records till then can be wiped off, so that it can start. It will make an entry of the checkpoint there. It will make an entry of the checkpoint so that you can be assured that up to that whatever was committed is made permanent into the database, so that even the log record is not required, because everything is up to date till then. So that you can see to that after that whatever you are writing will again start entering into the logs. Okay. So this optimization reduces the recovery time significantly, as only the transaction that occurred after the last checkpoint need to be reprocessed. Whether you are redoing or undoing can be done after the last checkpoint. So in case of concurrent transactions, how this will help and what additional effort has to be put in the log record, we will just see with the example in the next slot. Okay. Now restarting recovery. So whenever system crashes or transaction failure happens, we need to restart the process of bringing the database back to the consistent state. This will do, that is, whenever there is a crash, the subsequent restart will initiate a restart recovery. That means it is going to happen in two different phases, the redo and the undo phases. It has to identify what operation has to be redone and what operation has to be undone, because multiple transactions, interleaved logs, there is, you will not find in a serial transaction or a single process running, you will see to that the log records also will be with respect to one single transaction. But in a concurrent transaction, the log records will be interleaved. T0 has started, it has read, then it has written, then T1 has started, then T0 was reading, or T2 has started, or T1 was writing, something like this. One after the other, as they happen, it is being entered into the log. So in a recovery process, you have to select and identify a list which is redoing and which is undoing. So all those processes are going to happen in this case, where incomplete transactions will be undone and committed after the last checkpoint will need not require any, committed before the last checkpoint doesn't require any changes. Only checkpoints are the starting points for us. From their last checkpoint onwards, we have to perform the task. Any transaction that was committed after the last checkpoint will be redone, and anything that was incomplete or aborted after the last checkpoint will be undone. So these are going to be the procedures. So let us try to see this with an example. So especially when I say recovery after a system crash, I said checkpoints holds a very crucial role there. So checkpoints is a process of saving the snapshot of the application so that it can restart from that point after failure. So it is a point of time at which the record is written onto the database from the buffers. Now it shortens the recovery process because I am going to initiate my recovery process only from the last checkpoint, because till then everything is perfect. So when it reaches the checkpoint, the transaction will be updated into the database, and till that point entire log file will be removed, and then the log file is updated with a new step of transaction till the next checkpoint and so on. So checkpoint entry will be there in the log, so that you know that from there again you have to continue. So the checkpoint is used to declare the point before which the DBMS was in a stable state. Okay, DBMS was in a consistent state and all the transactions were committed. Now in case of a concurrent transactions or concurrent execution, the checkpoint will also have a list of all the transactions that are active during the time of checkpoint. Okay, just imagine, let me just tell you something. Maybe here I had a process T0 which was committed. Okay, now at this state I have a process T1 which was in operation. Maybe it was operating a variable xi with the v1, v2 values, let me just say 50 and 100, something like this. At this point, if I am going for a checkpoint, there will be an entry to the checkpoint where it says L will have T1. So what is the meaning of this? T0 has committed. So T0 you will not perform further. It is not half done, it is complete. Whereas T1 is in an incomplete state. I don't know, further transactions may be there, it may commit or it may abort. But what I have is a list of active transactions at the time of the checkpoint. That is the role here. L plays that very important role there. We will see how and what. Okay. This point you keep in mind, other things remain the same as regular checkpoint operation. Now coming to the recovery action, once the DBM has restarted after a crash, there is two phases, redo phase and undo phase. In a redo phase, all the actions are again replayed and updates of all the transactions are done by logging or scanning the log in a forward direction after the last checkpoint. So we have told up to checkpoint everything, the system was in a consistent state. So after the last checkpoint, somewhere before it could reach to the consistent state again, the system has crashed. So what is my task? So from that checkpoint, whatever has happened, I have to replay it. I have to replay it based on the log entry. That means what are the things I am going to redo it? Anything that was committed after the last checkpoint, okay, or any action that has been started. See, the log records that are replayed include log records for the transactions that were rolled back before the system crash and that has not been committed when the system crash occurs. So which was committed anyway you have to do, even in the situations where it was not committed has to be redone, then I will check based on the requirement whether it has to be undone. Okay. So let us just try to see what will happen during that time. So it also determines all those transactions which were incomplete in the time of crash and they must be rolled back. So I call it as a undo list. So during the process of redo phase, not only it will replay and update the things, but it will also make a undo list which will be come into action in the undo phase. Okay. So let's see what will happen. So the list of transaction to be rolled back, which we call it as the undo list, is initially set to L, where L is nothing but the active processes during that checkpoint phase. Okay. Now what will happen? Whenever a normal record of the form transaction, the object that it is modifying, then V1, V2, before and after values or redo only log record is encountered, the operation is redone. We said after the last checkpoint, whatever has been done is not been updated. That is why what I have to do? I have to redo it. Record entry is there, but I don't know whether that updation is there or not. So seeing this value, you redo it. So what are you going to do? This particular object you will redo means you will just get it to the next value again. Okay. So V2 is written. So this is the old value, this is the next value. So next value will be written there. Okay. Next, whenever a record of the form start is found, I will add it to the undo list. Why? I don't know, because I am coming from, see, last checkpoint was here. Checkpoint and list of elements are here. Then I go on seeing the transaction. I see that there is a transaction 32, start. Maybe meanwhile at down somewhere T3's commit may be there or T3 abort may be there or nothing may be there. So what do? I just put this T3 into an undo list, because in case if it was not committed, I have to cancel all the actions done by that. So I will add it into the undo list. Then whenever a log record of the form Ti abort or Ti commit is found, Ti is removed from the undo list. Now Ti abort is found, that means it is already before crash itself, undo operation has been done. So I just leave it, I just remove it from the undo operation. Or if there was a Ti commit, then in that case also I know that the changes were made permanent, that means I have already done the redo operation. See, look at this. After this statement, I would have had Ti commit. So I have done it to V2. So now my only task is to commit. So that is why from the undo list, I will remove it. So whenever a log record, okay. So at the end of the read phase, undo list contains list of all the transactions that are incomplete or that are neither committed or not rolled back. So such list is ready with me in the undo list. Okay. Now redo phase, I have done updations and I have also at the undo list. Now at the undo phase, I am supposed to work on undo operation or rollback operation with respect to each and every transaction that is there in the undo list. This is the undo phase. So in the undo phase, the system rolls back all the transaction in the undo list. So what it performs? It performs this rollback by scanning it backward from the last log record. It moves backward. So by scanning it from the last record. So what it will do? Whenever it finds a log record belonging to a transaction in the undo list, it performs the undo action just as if the log record has been found during the failed transaction. So it finds that record, okay, T2 is there or T3 was there, it is there in the undo list. So T3 has got a record of this style, T3 XJ, okay, then I have 50 and 100. Now because I have to undo, what should I do? I should see to that T3 XJ would get back to a value 50. This is that undo operation. So I will perform that because I know T3 is there in the undo list. So I am doing that. Then what is happening? When the system finds a TI start log record, that means TI is starting, that is T3 start I find here. That means T3 has started. So I have come in the reverse order. So all the operations that was performed by T3 has been completed in undoing. So what is that means? T3 is done there. So T3 can be removed from the undo list. So what you will do? TI is now undo, okay, undo list. It writes TI abort in the log record and removes TI from the undo list because I have done with it. Now no more it is required. So this has to be repeated till you complete all the transactions from the undo list. So undo phase terminates once the undo list becomes empty. That is, the system has found TI start log record with respect to all transactions that were initially there in the undo list. So after the undo phase, recovery terminates and normal transaction processing can resume. So the first thing when system DBMS restarts after crash, it has to perform this and then the normal operations. Quickly, let us try to see our system recovery after crash with this particular example. Now look at this. This is a log entry. At this phase, at this stage, I find that system has crashed. Okay. So up to this, it is like this. Now what is happening here? Where is the last checkpoint? The checkpoint is here. Then what are the transactions that will go into your undo list? The undo list will have T0 and T1. And remember one point, here if you observe here, after the checkpoint, T1 has committed and after the checkpoint, T2 has started and here T0 has aborted. When T0 has aborted, look at this, B value has been recovered. So what you will see is because it is aborted, I need not put it in the undo list because already B value is in 2000. So I need not worry about it. So that is what is the meaning of doing it. Let us try to do. So from here what it is going to do? It is going to redo the operations. Now look at this. It is going to update the C value to 600. Transaction T1 is going to update the value to 600. Now I see that there is a commit. Because there is a commit, this will be removed from the undo list. T1 is no more in the undo list. Remember that. Coming further, there is a T2 start. That means T2 has started after the checkpoint. So I don't know whether T2 completed, aborted or half done. I add it to the list. T2 is added to the undo list. Next, proceeding further, T2, A value is 500 and 400. I just make that particular operation there and I update it to 400. A value I update it to 400. Then I observe that there is a compensation log record where I need not do anything. B value is 2000, I just leave. T0 is abort. The moment it is aborted, I get to know that undo operation is already done. It has been updated here. So why should I do undo again? So cancel this also from the undo list. Now only one thing that is there in the undo list is T2 when I have completed or I have read the transactions log record from the last checkpoint. Now the redo phase is done. Now the undo phase starts here. What am I supposed to do in the undo phase? I move backwards. I move backwards and I need to perform the undo operation with respect to every transaction that is there in T2. So I come back, T0, T0, T2. There is a T2 here, undo operation. What will I do? I will resume the value of A to 500. Then I see T2 start. Now what is my task? Whenever I see start, I know that all the transaction with respect, all the operations with respect to T2 has been completed. So T2 is removed from the undo list. Now what I observe is undo list is empty now. We said undo phase will continue as long as there are items in undo, but now there are no transaction, it is empty. That means my recovery phase has completed. I have completed the recovery phase and I will be able to start my normal operation. So this is what it is showing. T2 is rolled back and this is very important. This entry is made after the log records. You have to add that recovery process also. Here we have undone T2. That is why there is a compensation record here of transaction T2. A value is restored back to 500 and we aborted T2. So T2 was rolled back. This entry is made. Okay. This entry is made here. This is what is it says. Start of the log, what will happen in the undo phase and what will happen in the redo phase. So it is in a consistent state after recovery, that is it has brought back to the consistency phase. Now the normal transaction can start again. Okay. Remember, so when we see, just remember all these operations, what we say, all these methods, interaction with concurrency control or transaction rollback or checkpoint or restarting the recovery, they all work mutually to enable robust recovery mechanism. The final idea is only to ensure data consistency and integrity in the presence of concurrent execution, because concurrent execution gives us the best benefit of maximum performance or improved performance. So in order to gain that, but at the same time stick on to the data integrity and consistency, we have to work with different methodologies. So they all work in that particular order. Fine, this is all about the transactions. So we have our transaction control commands in MySQL, which is going to be in your lab portion, which you will see in the next video. Thank you so much.